Good morning, students. So, till now we have completed with exercise 1.1 and 1.2. So, today I'll explain you the concept of function and its definition, and then we'll move on to exercise 1.3. So, what is a function? So, function is a box like this. It has an input and it does some operation here, and then it gives an output. Yes, suppose if I feed 2 to this input, then I'll be getting 10 as the output. When 4 is fed, then my output will be 20. So when I feed 7, then my output will be 35. So what is this box doing with the inputs? So probably you would have guessed it. It is just multiplying the inputs by 5. That is 2 times 5 is 10. So 2 into 5 is 10. 4 into 5 is 20. 7 into 5 is 35. So a function has an input. It performs some operation and then it gives an output. So this is called a function. So this is called a function. So the common way to represent function is f of x. So here the operation is multiple of 5, right? So 5x. So f of x is equal to 5x. Here f denotes the function, this x denotes the input, and this is our output. If I feed 2 here, that is f of 2, if I feed 2 in this input, then my output will be 10. So in the place of x I am substituting 2. Yes? Does it have to be x? No. It can even be a. That is f of a is equal to 5a. We can choose any variable as the inputs. It can be a, b or c or anything. Yes? So if I feed 2 here is equal to, then I'll get the output as 10. So f of something is considered as a function. So f of something is considered as a function. So again, now tell me, it is necessary a function must be f? No. It can be even g. That is g of x is equal to 5x. Or it can even be h. So it is not necessary that a function must be f. It can even be g or h or anything. So you don't get confused if the function is labeled with some other alphabet. Yes, understood, students? So this is the concept of function. So next we'll move on to the definition of function. Now this is the definition of a function. A relation f between two non-empty sets x and y is called a function from x to y. So relation between two non-empty set is called a function from x to y. If, so there is a condition. So what is the condition? for each x belongs to capital X. So this small x is the element and the capital X denotes the set. So for each x belongs to X, there exists only one y belongs to y. Only one y belongs to y, such that x comma y belongs to f. So what does it mean? To be a function, the condition is every output must have a single input. I'll repeat. Every input must have a single output. Yes? I'll explain you using an arrow diagram. So, first we'll check whether this represents a function or not. So, this is our input, right? And this is our output. Usually the first set is the input and the second set is the output. So what is the condition? To be a function, every input must have a single output. First we'll write it. So A is the input and output of A is P. So B as a output Q. C as the output as R. Now tell me whether this is a function. Yes, this represents a function. This a function because every input has a single output. Yes or no? A has only one output, B also has only one output, and C has also only output. Since every input has a single output, this represents a function. Now the next one. So 1 as the input as M, 2 as the output as P, 1 as the output as M, 2 has the output as N, 3 as the output as N. Now tell me whether this represents a function. Yes, this also represents a function because every input has a single output. So every input has a single output. Yes? So this represents a function. So the next one. A as the output X and B has two output, that is Y and Z. Now tell me whether this is a function. No, it is not a function because the condition for a function is every input must have a single output. But here the input B has two outputs. So this is not a function. Understood, student? So the condition for the function is every input must have a single output. Every input must have a single output. Yes? Suppose if an input has two outputs, then this is not a function. a function f from x to y. So function f from x to y is written as f from x to y. So we call this semicolon as from. So f from x to y. If f from x to y is a function, then if f from x to y is a function, then the first subdivision is the set x is called the domain of the function. So the set x, that is the first set, is called the domain. Yes, and the set y, the second set, the set y is called the codomain. So the first set x is called the domain of the function and the second set y is called the codomain. Next, the set of all outputs, of the elements of x under f is called the range of f. So the set of all outputs are called the range of f, or called the range of f.